Okay, so I promised to review or to go through it. I'll also make sure I post a clean video of this, or sorry, picture, because I'm not entirely sure this is the cleanest video I'll make ever. So let's go through these. So high points of the strong nuclear force. It's the strongest. It's a short-ranged force. It glues quarks together. To make protons and neutrons. Protons, neutrons. All right, it also holds the nucleus together. All right, next up we got the weak force or the weak interaction. It changes quarks. It's the shortest range. And it's related to radiation. Which is the whole thing with this changes the quarks piece. That brings up gravity. It's weakest. Infinite range. Depends on mass and distance. All right, that moves us on to talking about the history of gravitational force a little bit. So the scientist who actually came up with a constant was Cavendish. The general formula of the equation force equals product of the masses over the separation squared was Newton, but the actual constant was due to Cavendish. All right, so how does gravitational force change with distance? Inverse square. And with mass, it's directly proportional. That means whatever you do to mass, you do to force. Okay, so looking at that one, if we moved an object 4 times further apart, well, that'd be 4 times what we think we did to r. That means that 1 over 4 squared, 1 over 16 times the force. All right, if we double one of the masses, well, that's times 2 to the force. So we got times 2, we got 1 over 16, so 2 times 1 over 16 gives us 1/8 the original force. So if you change multiple things in the equation, multiply all your changes to find your final change. All right, direction of velocity in circular motion. It's tangent to the circle, which means that it's perpendicular to the radius. Okay, in what direction will an object go if it's released from circular motion? Same thing. Tangent or perpendicular to the radius in a straight line. Now, once it leaves, it can become a projectile, and then it can undergo a parabolic path. So if it's swinging around like this, and it's released at this point, its initial velocity will be this way. The actual path will be a parabola, because if it was vertical, it'd go that way. If it was horizontal, it would continue out straight. So it comes off straight, and then all those other rules of physics. Okay, if we launch an object horizontally, what happens to the horizontal velocity? Stays the same. And the vertical velocity accelerates due to gravity. All right, then we get to centripetal acceleration and velocity, and I'm sorry for the focusing of this webcam, it has issues. We'll get the general equation that AC is equal to velocity squared over r. It means whatever you do to the velocity, do the square of it to the centripetal acceleration. Whatever you do to the radius, do the same, the opposite, sorry, to centripetal acceleration. All right, now we get to look at a ladybug on a record. Some numbers didn't quite play as nice as I wanted them to when I set this up, or my math is having issues today. So we've got a force, we got a mass, and we've got a radius, and we're trying to find a linear velocity. Well, we know that force equals mass times acceleration, and we know that the acceleration is equal to v squared over r. So there's our equation. Plug in the things we know, 0.01 times 10 to the negative 6th equals 2 times, or 0.0 times 10 to the negative 5th times our velocity squared. All that over a radius of 0.09, because I really don't feel like writing that out in scientific notation. All right, plug it all into our calculator, take the square root in the end, and our final velocity will be 0.067 meters per second. All right, looking at number 12. In the absence of air resistance or other aerodynamic effects. So essentially, if we're pretending we're doing this in a vacuum, if you drop a bomb from or anything from an airplane, does mass matter? No. Oops. Well, what does matter? Initial velocity, particularly horizontal velocity, and height. Two objects at the same velocity dropped from different heights, higher one will go further. Two objects dropped at the same time from the same height with two different initial velocities, faster goes further. If everything else is the same, they hit at the exact same spot. All right, we've got gravitational force between Earth and the Sun, at least an approximation of it. But if we move the Earth out to 2 AUs when it wasn't 1 AU, that means that we doubled the separation between the Earth and the Sun. That means that to the force, we do 1 over 2 squared times the force. So we need a quarter of this. So we'll take that, plug it in, divide it by 4, and provided I typed it in earlier a minute ago, should be 8.85 times 10 to the 21st newtons now. Then here, this was a stunt. We had a Cybertruck haul a Ford, at least supposedly Cybertruck 1. If we assume they're 3 meters apart, sorry, this one's extra faded. Should be a 3 right here. And we have a mass of the truck. We have the mass of the Cybertruck. We want to know the force between them. Well, gravitational force is constant times mass 1 times mass 2 over r squared. So that means we get our 6.67 times 10 to the negative 11th times 2580 times 4,000, all that over 3 squared, which should come out to a gravitational force between them of 7.65 times 10 to the negative 5th newtons. And then finally, we have somebody who's running or on pace at least to do a 22-second 200-meter race, or a 44-second quarter mile if they can hold the pace. But the key point is they're running through the curve in lane 1 on an outdoor track. Standard radius for the curvature of the track is 36.5 meters. So we want to know the centripetal acceleration. Well, centripetal acceleration is velocity squared over radius. We know radius, we know period, or at least the time for this length, and we know a distance. So if we know distance and we know time, well, then we know our speed. So we can plug that in for v. Oops. Helps if I do that right side up. And then we can go solve for AC. Considering I did this a different way the first time and did it wrong. So 9.09 over 36.5. And we get 0.249 meters per second squared. Cool. Hope this helps. Bug me tomorrow morning if it doesn't.